Mm, Let us discuss about some electricity, a little electricity. Uh, in that, first of all, we need to know some electric devices what we are using in our daily life. At your home, at your home, ceiling fan, tube light, TV, a refrigerator, induction stove, electric kettle, your computer, mobile phone, all are electric devices. All are electric devices. When you are sending some electrical energy, then they will work. They will work. Light will glow, fan will rotate, your computer will get on, and you can watch the screen. Then your electrical energy converted into light energy and some mechanical energy. Before going to that working of that, we need to know a little bit more about electrical energy. In our lesson, in our lesson, our basic lesson, given that some electrical devices, storage of electricity in batteries, and a simple electric circuit by using a battery, connecting wires, and a bulb with a switch. So in daily life, we are getting some copper wires. Those copper wires we are using for connecting battery. And look, this is the symbol of battery and positive terminal, negative terminal of the battery. These are connecting wires. And here is our bulb that you can use a safety pin as a switch. As a switch. Look, this is open. Whenever you want to close it, you can close. What will happen when you are connecting a switch here, battery here, and this long terminal is considered as positive, and this short terminal is considered as negative? This electrical energy will pass through the bulb here. This is called filament of the bulb. And here, pin. This is a safety pin. Now it's open here. Watch, it's open. When we close, electrical energy pass through the bulb and bulb will glow. Bulb will glow. And this is called simple electric circuit. Simple electric circuit. And here, connecting of batteries. In general, we are watching batteries in remote control. Batteries in remote control. They are in this shape at one side, and on the other side you will have a heel like this, and this healing part is nothing but positive terminal of the battery, and this is the negative terminal. Suppose you are taking one more battery, like one more battery to connect this. We have a lot of options. Once again, you can take positive here, and here you can take a negative. Look, negative terminal of the battery. And when you are connecting this negative terminal of first battery to the positive terminal of second battery, whatever the electrical energy you are supplying will be boosted, and more amount of electrical energy is supplied to the bulb, and bulb will get a glow. This will get a glow. Look. So in this way, we have another way to connect batteries. Look, this is a positive terminal, that is a healing part of the battery in general, and this is the negative terminal of the battery. This is a positive. So here I can take one more battery here, positive and negative. Like negative. And here you can connect two negative terminals and two positive terminals with the help of connecting wires. This combination is called a parallel combination of our cells. They are dry. They are dry cells. Okay. So two cells connected in parallel and two more cells are connected in. Yes, we came to know parallel combination and series combination now. Yes. Some magnetic effects of current. When this electric current passes through a conductor, what will happen? Do you know what is compass box? Compass box which shows you north and south poles. North pole and south pole. And here widely used in sailing when you are going in boat or ship to get the directions in midway of the sea. You can use this compass box, which is the north, which is the south, which is the east, which is the west. With the help of this compass box, you can get this. So this shows you universal north and universal south. One more thing, this we are using for getting the poles of the magnet. Shiraz, do you know what is magnet? Magnet. This is a magnet, which is a in rectangular shape, and it has poles of north and south. North and south. The total magnetic strength is located at ends of the north and south poles midpoint. That is, the magnetic effect is very less. Here, the magnetic effect is very less. The strength of the magnet is less at mid portion, and it is more at the ends of the magnet. Okay. So when you are keeping this compass near the magnet, this magnetic needle will deflect, will deflect, and shows the north and the south poles of the magnet according to the lines, field lines, which are coming out or emerging out from the north pole and enter into the south pole. In this way, the magnet also will deflect, will deflect, and it shows the north and the south poles of the magnet. It shows the north and south poles of the magnet. It means if you are taking a compass box and keeping it near the magnet, it will deflect and it will show the directions of the magnetic field. So this same thing you can observe. The same thing you can observe when a current passing through the conductor. When a current passing through the conductor. Suppose I'm taking a conductor here. Let the current will pass through this conductor, and from here the conductor it is. Here the current passes through the conductor. Here I can take the switch and circuit is completed. From A to B it is a conductor, and this is made up of soft iron. And if you send electric current by closing this switch through the battery, which contains positive and negative terminals, and when current passes through this, it behaves like a magnet. How can we identify? If you place a compass box beneath the wire, that is under the wire, this compass box deflects. This compass box deflects. Why it deflects? When you switch off, it won't deflect. When you switch off, its direction is in this way. It shows north and south. When switch it on, suddenly this deflection or this arrow mark turns to the horizontal, moves towards the horizontal. This is deflected. We know when this compass box placed near the magnet, then only it will deflect and it will align or it will arrange its needle along the direction of magnetic field. The same thing we are happening here when you switch it on. When you switch it on, when you off this one, this won't deflect. It will shows its a regular direction, that is north and south poles. When you connected it on, switch it on, then it will shows other directions. It means that this behaves like a magnet. So, for example, here when you are taking a nail of a lot of turns like this, and here you are just turning your wire, copper wire, and connecting the whole thing to this battery with the help of a switch, and you will switch on this one. The current passes through this, then this whole needle behaves like a magnet. This is the magnetic effects of current. Magnetic effects of current. And current passes through this. How can you know that current passing through this? When you are connecting ammeter, 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 which will gives the measurement of current, that how much current is passing through this wire, will be given by ammeter. Okay, so we got students today, we got some information regarding electrical appliances at our household purpose at our house, and those are working when you are supplying electrical energy, and that electrical energy converted into light energy and some mechanical energy and some heat energy, some electric kettles, water heaters, geysers, they all will get heated up. Okay, induction stove, including induction stove. So that heat energy converted into lot of another forms. Here you can say that conservation of energy. One form of energy is converted into another form. So one more thing we got from that, some batteries are there. Most important role they will play in our mobile phones, remote controls, AC remote controls. Nowadays, electrical vehicles they are using widely batteries. Yes. So these batteries, what they will do, they will store electrical energy as a chemical energy. Whenever you need that chemical energy converted into electrical energy. Okay. So now one more thing. You can connect the batteries for glowing bulbs in a simple electric circuit with the help of a switch. When you connect it battery, that means it means battery connected in series with a bulb, and with the help of a switch, the bulb will glow when you switch it on, the bulb will off when you switch it open. Okay, one more thing, magnet. You all know that magnet, which has north and south poles, the total strength of the magnet is located at ends of the magnet. At middle of the magnet there is no magnetic strength, it is, even though it is very less. And by using compass needle, we can get the idea that which is a north pole and which is a south pole. We are using that compass needle widely at boats, ships, to get the idea at midway of the sea that where is north pole, which side is the south pole, which is the east, which is the west, in midway of the sea. Why it shows? Why? Because it shows the directions of north and south poles of the universe. So it is very easy to say. The same thing when you are keeping that. The same thing occur when you are keeping that compass box near the magnet. It will show the directions of the magnet except showing the north and south poles of this universe. Because the magnetic field lines are arranged and they are traveling from north pole to south pole. The information will be given by compass box, this one. And next, when you are taking a copper wire and connecting a battery with the help of a switch, and when you switch it on, some electric current is passing through this wire. And when you are bringing this compass box near to this wire through which current is passing, it deflects. We know that previously that it deflects when you are keeping it near the magnet. Now it is deflecting. It means that this wire AB behaves like a magnet. And the same thing you can watch here also by taking a screw here, connecting an ammeter. Ammeter is a device which can measure the current, that how much current is passing through the wire. And here it is a battery which supplies electric current through this wire. How much electric current is passing through this wire you can measure with the help of ammeter. Once you are sending the current through this wire, and the whole current will passes like this. and this nail behaves like a magnet. Nail behaves like a magnet. This is a magnetic effects of electric current. In our next class, we'll go through. Okay, bye.